record. All right. So here we are back at faces, vertices, edges, oh my. And we started this last recording. So if you weren't part of that, go look it up in the YouTube playlist. It'll be at the bottom. And we're first considering the Platonic Solids. And if you dig around on the pages of the Platonic Solids, they give you the answers to the faces, vertices, and edges, but we tried to count them ourselves. Now this time, I kind of brought a special surprise, at least for me. I'm gonna switch the camera for a sec. Do that, stop sharing. All right, so here is me and my icosahedron. So usually in this class, we're together, and I bring in a ton of different kinds of things, toothpicks and popsicle sticks and glue guns and soldering irons, and we build 3D stuff. So this was built by somebody in my class, I can't remember who, still got glue stick strings on it. Last spring, somebody made this. This is an icosahedron. Notice that each side is a regular triangle, an equilateral triangle, and it turns out there are 20 such sides. And so I'm gonna have you try to help me count these. The other way I was trying to count them last class, and let me go back to my notes for a second, was in my notebook, I took a screenshot of, let's grab this icosahedron here, and I tried to draw on it. And they made this like it's out of glass, so you can kind of see through it. So let's see, I want here maybe. Yeah, that's the one. Oh, and that's going to be kind of hard to do at that angle. My eyes are having a hard time dealing with that, but I'm going to copy it anyway and hope for the best. How about you guys? Does that make sense to you as you're looking at it? The 3D one makes more sense, but it's kind of hard to count parts of a moving object. So add to, I'm not ready to add it because I'm not on the right presentation. Let's switch to last class right here. So we were filling out this table together. We got as far as the dodecahedron. I made another shape called Gary's L-hedron. I'll show you in a sec. I tried to draw a picture of it here. And we're gonna try and do, here's the dodecahedron. We're gonna try and do the icosahedron. All right, so wish us luck. Now we're ready for a screenshot. Y'all still with me? Haven't put you to sleep yet. Current page. So it shows all of the edges here and all of the vertices. So I'm gonna try in a minute to go around and color code those and count them. But first I'm gonna try to do it live with you by looking at my shape here. So stop sharing again. All right, here we go. Okay, so let's see. Do this right here. Push pins. And I'm going to put one pin up here. I'm going to stay. So that's going to be like the top vertex. And straight across from it, there's a bottom vertex on the other side. That's kind of symmetric. Oops, that pin did not want to stay in there. Trying to stick it in without breaking anything. All right, so there's the push pin. I'm going to call that the top. I'm going to call this the bottom. Okay, so I got pins in the top and in the bottom there. And then we're going to try and go around and count. Let's start with the vertices. So I've got the push pin right here. And then, let's see, angle this way toward you. And then I have 5 triangles coming around that. So that means there's 1, 2, 3, 4, 5 going around there. And then there's kind of a band of triangles going around the belly. And then on the other side, I kind of have a symmetric thing going on, right? There's this opposite vertex, and then there's the 5 vertices coming around. Okay? So I think what that means, if I'm doing this right, is there's 6 I can see directly when I look at it at this angle. And there's another 6 on that when I look at it from that direction. So I think I'm counting 12 vertices. Okay. Another way to think about that would be to hold it at the top and then kind of count going around. So at the top I have 1, and then I have 2, 3, 4, 5, 6, then I'm back to where I started. And then underneath, I have, starting here, 7, 8, 9, 10, 11, that's back to where I started, and then 12 at the bottom. Okay, so I'm fairly certain I have 12. Does anyone want to argue with that? I make mistakes all the time. You guys are well aware of that. You've seen me do this stuff before. Making mistakes is human. All right, so I'm pretty sure, again, this is the icosahedron. And the icosa stands for 20 faces. Hedron is a side or a face. So we get the 20, and we could double check by counting those two in a sec, but I believe there's 12 vertices. The edges are going to be harder to count, I think. Vertices. All right. So I'm going to switch back to my camera view. All right, here we go. Yes, I need to make this bigger for me. All right, so I'm trying to watch myself as the camera as I'm doing this. Okay, so let's see, double check the faces, right? So from this, what I was calling the top vertex, I clearly have 5 triangle faces going around there. And then coming around the belly, let's start with this orange one and work our way around back to it. So that would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then I'm back to the orange one. So there's 10 around the belly, there's 5 on the top, and guess what? There's 5 on the bottom. So 5 and 10 is 15, and 5 is 20. Okay, yeah, this does have 20 faces. Oh my, the edges. Okay. Now this one is a little bit complicated because every 2 of these popsicle sticks is actually only really 1 edge. So that's hurting my brain thinking about that. I could count all the popsicle sticks and divide by 2. Okay, so let's see, how do we go about counting these? Well, if I'm just looking at it from that central vertex there, let's see, this is the downward one. Ooh, weird stuff's happening on this. You can see the river right through this one. Interesting, right through me too, that's bizarre. Okay, anyway, focus, Gary. So we've got what? 1, 2, 3, 4, 5 coming out from the vertex point. That makes sense. And then starting here at the top, then we would have 6, 7, 8, 9, 10, takes us back to the top. And then we got to work our way around the belly, and that kind of is like a zigzag pattern. So where's that orange one? Let's start with the orange one. So I'm going to start on this side of the orange one. So let's see, where was I at? 10? Yeah. So then it's 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, and then I'm back to orange. Okay, so I'm up to 20, and then we flip and repeat at the bottom, working our way around the edge from the bottom here, 21, 22, 23, 24, 25, and then from the vertex, the bottom vertex, 26, 27, 28, 29, 30. Looks like it's 30. Oh man, that was tough. Relatively speaking, this is actually a river in Central Oregon. I think it's the Mackenzie River. I would like to go there soon. Let's see, where's my share button? There you are. Okay, so here we are back here, and so we think there are 30. So the only other way I know to do it besides holding it and hoping I do it in a very systematic way, these are edges, sorry, edges, is to go through here and trace them. And I'm gonna skip that now, but I'll do it later because that would be a very boring thing to watch. I think what we just watched was boring enough. So you guys still alive? Can someone give me a thumbs up or yeah, I'm still here kind of thing, or no, I'm washing the dishes or taking the dog to go potty? Anybody out there still? Oh, thank you, Olivia. I'm glad you're still with me. All right, here we go. So what did we find? Icosahedron. It had 20 faces. And let's see, we did vertices next. I believe that was 12. And it had, no, that doesn't seem right. Was it? Where'd you go? Oh, maybe that was right. Icosahedron. 12 vertices, 30 edges. Okay. 12 vertices and 30 edges. Okay. And then we're supposed to try and find a pattern to these three numbers that matches a pattern to those three numbers. That's a pattern to these three numbers. And let's see, 4 plus 4 is 8, and then there's the 6. And they don't all add up to the same number, notice, because these keep getting bigger and bigger, so that wouldn't work. 6 plus 8 is 14. 8 plus 6 is 14. 12 plus 20 is 32. 20 plus 12 is 32. Does anyone see a pattern there? Thank you, Giselle, for letting me know you're there. No, I thought
Could a pattern be add the faces and vertices together and then subtract 2 to get the edges?
Yeah, I think that's right. Let me see. So let's write that down. So you say take the faces plus the vertices, subtract 2, and that should be the edges. Okay, so check for the icosahedron. Actually, let's do something we knew was right, the cube. That would be 6 plus 8 minus 2, which is what, 14 minus 2, which is 12, and that is the number of edges for the cube. Yeah, you got it. That's the formula. And there's different variations on it. Some people write it as faces plus vertices equal edges plus 2. Okay, so that's another version of the same formula. But this is the cool thing. If it's a polyhedron and you can correctly identify the faces, vertices, and edges, this pattern always holds. So with that in mind, I brought a few other polyhedron with me, some of my favorites, and let's take a look at them. So I'm going to switch to camera view again. All right, so you remember this thing we made before? It was that truncated tetrahedron. And so if I open it up from that circle folding exercise that we did, it could be a tetrahedron if I don't fold those flaps down. And if I fold the flaps down, then I get that truncated tetrahedron. So this is a polyhedra. And just to see how many faces it has, if I hold it like this, it's got a little top and a bigger bottom. So I have a top and a bottom, so there's 2 faces, and then 1, 2, 3 around the edge, right? Because it's got a triangular top and a triangular bottom. So this has 3, 4, 5 faces. So I'm going to add that to my worksheet. Where's the right button? Way too many buttons here. I think I'm getting computer button fatigue. All right, so I'm going to add some special ones. So the one I'm going to add to this, and that was this, like the second page of that this activity we're working on. So just remind you. So here we were supposed to come up with 3 other polyhedra. So I'm going to put the truncated tetrahedron for this one in my notebook. And I think I'll add that with red. Trunk tet. There we go. And the trunk tet has 5 faces. And so now we need to figure out how many vertices and edges it has. I don't know if I can draw it adequately. I'm afraid to try right now. So I'm just going to show it again. Oops, wrong button, right button. All right, so let's see. Vertices. Well, that's not too bad. There are 1, 2, 3 on the little triangle at the top. And then 1, 2, 3 in the little triangle at the bottom. So it has 6. It's pretty straightforward. So we've got 6 vertices. Edges, that's not too bad either on this one. So as far as edges go, and let's say I brought a marker to draw the edges in so we can see them better. We've got this one here, and that's, you can't even see that color here. Oh, it's because my marker's not very good. Darn it. Oh, well. So again, I have 1, 2, 3 on the top. And then coming down from the top, we have 1, 2, 3 to get to the bottom. So that's 3 plus 3. And at the bottom, there's a, ooh, sucker. There's another, oops, that's not the bottom, that's the bottom. 1, 2, 3. So I have 3 on the top, 3 coming down to the bottom, and 3 at the bottom. So that should be 9. Share. And so if we take 5 plus 6 and then subtract 2 from that, that's 11 minus 2 is 9. It checks out that pattern. All right, let's check out Gary's L tetrahedron. And I attempted to draw it, but I'm going to show it to you too. I don't think we've ever played with these toys in class. These are called omnifix cubes, and I made this kind of little chair out of them. You see my little chair type thing here? And I think maybe that light's too bright. Still a little bit of glare. Okay, so here's my chair-shaped figure. Okay. So I'm going to try and count the faces, vertices, and edges. Now this is more complicated than the other figures because this one caves in on itself, right? It is the other figures we've looked at are all convex polyhedra. So we're branching out here a little bit. All right, so here's me attempting to draw it. And I was attempting to count before you guys arrived the faces, vertices, and edges. So I drew it over here on the side. Okay, so faces, well, it has a top and another top and a bottom. So for the faces, let's say I've got one on top and I've got another part of the top, and then it's got a complete bottom sitting on the ground here. So there's another face there. And then the sides, right, we've got this L-shaped side and there's an L-shaped side on the other. So there's two sides that way. So we've looked at it straight down, right? And from the top and bottom, we looked at it from, let's say, the front and the back. Now we got to go left and right. So I've got this face here to the right and this face here to the right. And then I've got that other one to the left. So it looks like it has another 1, 2, 3. So what's that? 3 and 3 is 6 and 2 is 8. So my belief is this thing has 8 faces, this L-shaped chair type figure. So it's kind of like two rectangular boxes stuck together. All right, if we count the vertices, that's not too bad. I've got 1, 2, 3, 4 on top. And then in the middle here, I've got another 1, 2, 3, 4. And then here I have 1, 2, 3. And then there's a hidden one back here on the bottom that we can't see because there's actually a hidden edge if this was made of glass coming down through. Oops, it's supposed to connect over to there. That did not come out very well. You kind of get what I'm drawing there. I might have to do that over. Undo, and then eraser. Let's see, where would that other side be? I go through like this, dot, 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 and then down from here, dot, 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 dot. It'll meet around there, and then over to here. Okay. So I've got 4 and 4 and 4, and so there's the 12 vertices I believe it has. The edges are going to be a little harder to count. I'm going to try that with a highlighter. And this took me like 3 tries holding the object in my hand, but I think this is going to be easier. So let's do a skinny highlighter. All right, so starting at the top, I have 1, maybe that's too thick. Let's try the skinny version. We have 1, 2, 3, 4 from the top. Then we have to come down from the top, right? So that's going to be 5, 6, 7, 8 to come down to here. And then 9, 10, 11, 12. And then we have to come down again, 13, 14. And then we have the bottom, 15, 16, 17, 18. And my earlier count found 18 also in a slightly different method. All right, so what happens with these numbers? Do they behave according to Euler's formula on a concave polyhedra? So 8 plus 12 minus 2. Yeah, that's 18. It works. Woo! Okay, so I think I'm going to stop there. We're quarter past the hour, and you guys might have some other stuff to do. Let's see, can we make a relationship between the dodecahedron and the, oh my gosh, Giselle, you're so awesome. Thank you for making that comment. And I'm glad you made, okay, so Giselle made, oh my gosh, you're awesome. Yes, okay. So Giselle's comment, I'm gonna read it in case you didn't see it in the chat. Can we make a relationship between the dodecahedron and icosahedron faces and vertices because they're flipped, okay? So, right, check it out. So the dodecahedron and the icosahedron, the 12 and the 20 are swapped. The same thing with the cube and the octahedron. Okay, so here's the beautiful thing, and I'm going to bring a friend of mine over to help show it. So I got to show the camera. Hopefully I can do this properly. Totally forgot I brought this with me. And Giselle asked the question. Yay. Hello. All right. Be right back. I'm coming. Okay, so I brought my friend Spider-Man here, and Spider-Man is hiding out here in this little web. And the web he's hiding in, I'm gonna have to get out for a minute, Spidey. He's sticky. It's all that spider power. Oh, sorry, bud. Okay, so Spider-Man's out, and this thing right here was me with a soldering iron and a bunch of little brass rods making, what shape do you think this is here? Pentagonal sides, they're all the same. This is the dodecahedron. Now, sorry about the glare of the lights, but this paper shape here, shuffle it back, find a good angle there. This is supposed to be a paper version of an icosahedron, but the glare of the lights is not helping in here. Okay. And I designed these so that if you were to mark the middle, the center of each of these pentagonal faces, and then connect them all, what you would get is this icosahedron. And these two shapes are called dual shapes because, like Giselle pointed out, they swap faces and vertices. So again, the way that swap works is we find the center point of every single face on here. And then what we do is we make edges connecting all those center points instead. And if we look at the shape that gets made based on that, we find in the case of the dodecahedron, we get an icosahedron living inside of it, and vice versa. If we made midpoints of all the sides of the icosahedron, all the faces of the icosahedron, and connected all those midpoints, we would find the dodecahedron. So I think this other one might help me show that. So here's the other icosahedron, and let's imagine that push pin there. So we find the midpoint of each of these triangular sides. How many triangles are there? There's 5, right? And if you connect those midpoints, what have you made with those 5 points but a pentagon? And a dodecahedron is made up of a bunch of pentagons. So it turns out the icosahedron and the dodecahedron are called dual polyhedra because one can be built from the other. And the same thing happens with, let's get my desktop back, the octahedron and the cube, the hexahedron. So if you were to mark the midpoint of each face of the cube and then connect those, what you would make from those connections is an octahedron and vice versa. And I think Wikipedia has that here. Let's go back. Dual polyhedra. And let's see, did I actually, I don't, somewhere I've seen a really good image of, you can see one inside the other. And I tried hanging my paper one inside the brass one and it didn't, I did not do a successful job. So I just hung them next to each other instead. I will make a note to try and find a good illustration of that. But that's an excellent observation. Okay, so all these formulas in this page, that's just really weird, geeky stuff. Don't worry about that. But they do just give some basics. And notice here, they do have the faces, vertices, edges, and faces table that we were building. So at this point, let's see, where are we? We're almost done with this activity. We did it for the Platonic solids. There's only 5 of those. And then let's see, what did we just do here? We just did the truncated tetrahedron. We did my L-shaped figure. And I don't, if you remember last week, or last class, if you weren't in here Monday, I recorded this Monday, and it's in my notebook. We did an Egyptian type pyramid. Where is that sucker? Yeah, we did it for this Egyptian type pyramid. We checked out how many faces, vertices, and edges it had. And also last class, we did the triangular prism, and we also did it for the pentagonal prism. And I apparently didn't write that down, but I remember talking about it. And they're not here, there, or anywhere. Okay. So hopefully you have enough information to finish this and turn something in. So again, what I'm hoping for is this table filled out, and then for the other part, write down the name of the shape, or maybe you have a picture of it you could insert, and then how many faces, vertices, edges, and then show the relationship for it. Let's see, what do I have? Oh, nothing to submit. Oops. Let's fix that so you can submit. And then another thing, I think most of you are pretty good at submissions, but I have some students in other classes that still have trouble submitting. Submit online, and then either a text entry or a file upload. Canvas recently fixed the text entry, so you can upload images and display them. So I just want to demo that real quick in case you haven't done it before. So if I hit submit for this assignment and switch over to text entry, and you can't do a text entry and file entry in the same submission, but you could do one after the other. So with the text entry, if I had a picture of something I wanted to include, I just click the embed image button and then switch over to Canvas. And then I think you have to go to My Files, but does Course Files work? No, it's gotta be My Files. So Course Files, those are the teacher. My Files, those are yours. And then you can upload any file you want and stick in there. So let me just pick something I can put in there. Let's, I don't know what this is. Regular pentagon flower, sure, why not? Actually, no, let's do the spherical hedron thingy. Open. And then it's good etiquette to give it a alt text. That's for people with screen readers. And so it takes the file name and says, that's your name. So spherical hedron, maybe. And then the size, double check that. Usually you don't want to go much wider or taller than 600. So I'm going to take the bigger dimension and knock it down to 600, or maybe even 500. Otherwise it's going to be too big for the screen. 500 by 485, that's not too bad. That might even be too big, let's go 400. And it'll automatically calculate the other one. And then you click update and it slaps the image in there for you. So you could put images in there and then write about them. And then submit them. And if you had a file, like a document or a PDF that you wanted to put to, then you would have to first submit this, and then resubmit anything extra that you want. So if you have a spreadsheet or a PDF or a Word doc, you could add that here too. And you could do as many submissions as you want, and I see all of them. So occasionally I have people that do submits in multiple parts. All right. Oh, wow, what a full day. Was that another question? Can we make correlation between multiplication and division with this principle? So I don't know about that. Can we make a correlation between multiplication and division with this principle, with the dual principle? Good question. So off the top of my head, the only relationship I know between the faces, edges, and vertices is Euler's formula, and that's just an additive expression. The duals is kind of a physical thing where the vertices and faces get swapped, and the geometrical version of that is just find the midpoint of each face and connect the midpoints, and then that makes a version of the dual shape with edges. And I don't know a lot about duals outside of that. Like, I'm familiar with them for the Platonic solids, but if you get a more complicated concave solid, like I mentioned Archimedean solids the other day, then things get wild and crazy. Archimedes, how do you spell Archimedean? Solids, there they are. There's some really wild shapes that you can make with just polygon faces. And I think this was a pretty good page for them. And every one of these certainly has a dual. You've probably seen these kinds of fancy lanterns around that people make and buy. And some of them have really cool names, like the rhombocuboctahedron and the okay, that too. I can't pronounce them very well. And then they have nets for them. We'll talk about nets, I think, in chapter 11 a little bit. That's like a flat paper version that you can fold and tape into the actual object, which is kind of fun. And each of these has a dual. And the dual is achieved physically by, again, finding the midpoint of each side and connecting them, which I think in general switches the faces and the vertices, but I'm gonna have to look up on that. So no, I don't know about a formula for that, especially when we get into more complicated shapes, but I'll think about it. Okay, so let's see, we had questions there. So don't forget Khan Academy, and if you missed assignments in Khan Academy, let me go there now in my student version of Khan Academy. It should take you to the what they call the learner home. And if you have other courses in here, you want to make sure you switch to the math MFES 3 assignments. And so this week I assigned 4 things. 2 are videos, which are optional, and 2 are 7-question, identify the 3D shape kind of thing. And if you missed anything, they're in past still. And anything that has a star on it, I'm hoping you have a grade on it. So you might want to go back and double check. So I'm going to look at these again. If it was a triangle or a document, no big whoop. Those are optional. But anything with a star was something I expected you to do. And they ranged from 4, 7, or I think some of them had 5 questions. There might even been a 9-question one, but I don't think so. I think they either had 4, 5, or 7 questions. So they weren't very long. So please go back and do those so I can record a grade for you in Khan Academy. And you can still do late work in Khan Academy. I just have to go look and find it. And if I made a mistake looking, please let me know. All right, that's it for now. Again, this week is relatively light compared to other weeks. We got the Khan Academy assignments, and then we have the faces, vertices, edges, oh my, Euler's formula, and show me a cool 3D object. So if you could post that soon. And then starting to work on the chapter, let's say, no, we have one more section to cover in chapter 10, section 10.4, which is about symmetry. We'll do that next week. That should be relatively short too. So this week and next week will be a little lighter than the past. So hopefully that'll give you some breathing room. All right, so unless there's further questions, take care and have a fantastic day. Thank you for playing with me today. I'm gonna head out.